Consider a particle moving along a curved path from some initial position to a final position. And we're writing the infinitesimal displacement vector and the forces acting on it in Cartesian coordinates, where we're considering friction between the particle and the surface. And I've drawn the forces at the center of mass of the particle because we treat it as a point mass. And here we have theta as the angle from the horizontal and this infinitesimal displacement vector. Now suppose we want the work done by the friction force. Well, that's the integral of the dot product between the friction force vector and the displacement vector. So if we divide through by ds, and then multiply the result by ds, so we haven't altered the integral, where ds is the length of this displacement vector, well dx ds is cosine theta, and dy ds is sine theta. So this integral can now be written as follows. And factoring out the friction force, we obtain the following result, where cosine squared theta plus sine squared theta is 1. So therefore the work done by the friction force depends on the path that the particle takes. So we say that the friction force is not conservative or dissipative. Now if you evaluated the work integral to find the work done by the gravitational force in a similar way, well, what you would get is the following integral. Which you would evaluate from some initial position of the particle to some final position. So therefore, no matter what path the particle takes, the work done by the gravitational force is the same. So therefore, if the particle returns back to its original position along a different path, then the work integral for the gravitational force over a closed path is 0. So therefore we say that the gravitational force is a conservative force, or it does not dissipate energy.